We're going to talk about Angles Anonymous. Our AA, this is our 12-step program for doing similar triangles. So we're going to talk about angle-angle similarity, and this is with triangles. So before we start that, can anybody remind me, it's not the triangle sum theorem, what the third angles theorem states? Without looking in their book, you should understand what the third angles theorem states.
It says if two angles are the same, then the third one is the same.
Good enough. I'll take that. It says if two angles in one triangle are congruent to two angles in another triangle, then the third angles have to be congruent. Common sense, right?
I remember that one now.
So when I talk about angle-angle similarity, when I have two angles in one triangle congruent to two angles in another triangle, it automatically is going to imply that the third angles are also congruent. I just want you guys to understand that. Okay? So angle-angle similarity. In a triangle, normally we would have to prove that all three sets of corresponding angles are congruent to each other, right? Because a triangle's got three angles. Our definition of similar figures said that, hey, if three of the angles were congruent and the side lengths were proportional, then they're similar. Well, you only have to do two sets of angles in order for that to work. So the first thing you're going to do tonight is you are going to, in your Postulates and Theorems book, do Postulate 22, which is the angle-angle similarity postulate. And I'm just going to read it in class and we're going to go through some examples. It says, if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. So not only are the third angles congruent, but because those three angles are congruent, they have to be similar. So if you can prove two sets of corresponding angles between two triangles are congruent to each other, then those triangles are similar. And if those triangles are similar, what do we know about the relationships between their sides? It's the P word. They are proportional. Got that? So again, we're just building on 6.1 and 6.2 using some facts that we already know. Do I need to prove that postulate?
No.
Why not?
We should already know it.
It's a postulate, and postulates are facts that cannot be proven.
Oh.
You will see that probably on your second semester final. What is a postulate? What is a theorem? Remember those week 1 definitions?
I thought you were talking about
Please turn your books to page 377.
377. I know. I messed up again.
Okay, that's fine.
377.
So first thing I'm going to do is I'm going to read through example number 3, and then we're going to go to the guided practice at the bottom. So we are getting to the point where our story problems in the geometry book, it really helps for us to draw a picture. Okay? The types of stuff that we are going to be doing from this point on are where the focus is on the Smarter Balance test. Okay? Talking about similar triangles, talking about similar figures. And we get into the next chapter, trigonometry, the following chapter, circles. So example 3 says a flagpole casts a shadow that is 50 feet long. Oh, those are stripes. What shape is that?
That's a right angle.
That's this. There we go. And what was this distance? 50 feet. Because that's a shadow. Sun's up here, flagpole's out here, shadow goes all the way down here. And you end up with a right triangle, right? It says at the same time, a woman standing nearby who is 5 feet 4 inches tall. 5 feet is how many inches?
Like 56.
5 feet is 60. 60 plus 4 is?
64.
So you have somebody standing nearby that is 64 inches tall that casts a shadow that is 40 inches. Notice this angle and this angle are congruent to each other because the sun is in the same spot at the sky for both of them. So this is person. Okay? That's like an Atticus. Okay, it's a Haley. So you got 5'4", cast a 40-inch shadow. Okay. So 5'4", cast a 40-inch shadow. This thing is 50 feet, and we want to know how tall it is. Okay. What do we know about this? Well, hey, that angle is congruent to this one because the sun's it's at the same angle in the sky for both of them. We know that all right angles are congruent. And based off our angle-angle similarity postulate, we know that this triangle is similar to this one. So these sides have to be proportional to these sides. So I'm going to pick a letter, our favorite one, X, and we are going to write a proportionality statement. And when I do proportionality statements on similar triangles, I make sure they're drawn in the same orientation. And then the next thing I do is I figure out where my X is, and that's the first thing I'm going to use. There are two ways for me to write this proportion. I can either go right side over bottom equals right over bottom, or I can use right over right equals bottom over bottom. And that's the one I'm going to do.
Okay.
I'm going to do right over right equals the bottom one over 40. Now, one thing I want you to notice, what are the units in this one? What are the units in this one? Watch this, though. Watch this. This is a feet. This is in inches. This is in inches. What's going to happen when I multiply this over to here? The inches are going to be on the top, right? So that the inches are going to cancel. So my final answer will be feet. I want you to realize I can have mixed units as long as the units are the same for each triangle. Like these are inches and these are feet. That's okay. I couldn't do feet here, write 5 feet 4 inches and then 40 inches. I have to convert them to a common unit. So we're going to do the quick simplification first on this one. 50 divided by 40, 5/4. That was tough, right? Get rid of that extra zero. Then I can simplify top to bottom, and I can simplify left to right before I do my multiply stuff. Nothing to simplify here, but 4 goes into 64 how many times?
8? No. Is it 8?
No, it's 16.
Oh my God.
Because 64 is 4 cubed, okay? Now I can get rid of this 16 by multiplying by 16. If I multiply by 16, I multiply this one by 16. 5 times 16 is 50 plus 30, which is 80 feet. So that flagpole would be 80 feet tall, casting that 50-foot shadow. Yes, Sean. Let's say we have a shorty out there that's 58 inches tall. How long is their shadow?
Actually, I do
So now let's say I have somebody that is 58 inches tall. How long is their shadow? So please work this on your own, and then I will go back and help you. Can somebody please raise their hand and tell me what proportion they set up? Well, what did I say? The first thing to do is figure out where your X is. Good. So bottom over bottom, X over 40 equals right over right, 58 over 64. So first thing I'm going to do is I'm going to do the simplification. I see that 4 goes into both of these. 4 goes into this one 16 times. 4 goes into this one how many times? I notice that a 2 still goes into both of these. 2 goes into this one how many times? 2 goes into this one how many times? Okay, I notice a 2 goes into this one and this one. 2 goes into this one how many times?
4.
And in this one? 29. Because it's 2 away from 30. Right? 2 away. It's actually 2 away from 60. So that would be 29. So the final problem I have, now again, you can multiply this whole thing out and get the right answer, but I like to do it so I don't have to use a calculator. So I'm going to take 5 times 29 and get 145 fourths. Now let's turn that into inches. This is one of those where we're actually going to want to do some division. 4 goes into 14 3 times, 2 left over. 4 goes into 25 6 times with 1 left over. So it'll be 6 1/4 inches. I just set up the proportion and solved the proportion. That's why I think Chapter 3 of Algebra 1, we spent an entire chapter of just doing proportions. Okay. Are there any questions on those setups? So, like I mentioned when I had the video camera turned off, we need to talk about applications in the real world because this is where the story problems are going to start to come in. Okay? So the first typical problem was one that we already drew, where you have the sun up here, you've got some object that's this distance tall, you've got somebody else that's like that distance tall, and you can figure out distances of shadows. That's because, hey, I've got the little triangle and I've got the big triangle. Notice that this angle is the same in both of them. Both of these are right angles, and that's what gets me my angle-angle similarity. Any questions on that?
No.
How many of you played air hockey before? How many of you guys played pool before? How many of you guys have played basketball before? Okay.
I seen you play basketball. Yeah, I broke your ankle.
So here's the thing that you're going to want to know from physics, from physical science. So, from physical science, you should have learned when light, bowling balls, pool balls, stuff like that. If it's going at a straight like this angle right here is my angle of incidence. It's going to bounce away at the exact same angle. Okay? And that's just due to that's due to gravity and conservation of energy. But so like here, if this piece is like this, and this piece is like this, notice that's a right angle. That's a right angle. Theta is going to be congruent to theta, and again, you're going to end up with an angle-angle similarity postulate. That's going to let you do proportional pieces on these things. Notice that these two triangles are not in the same orientation. What I always do when I get ready to actually do my math work on these is I will redraw both triangles in the same orientation so I can think about the corresponding parts matching up directly. Any questions on that one? The other type of problem that we're famous for in these types of things is we learned how to construct midsegments. We had a couple sections on midsegments where we connect the midpoints of a triangle. You know, the midpoints of two sides of a triangle. What do we know about that midsegment? Okay, so this, if that's the midpoint and that's the midpoint, what are the two pieces I know about that midsegment? What, Sean? We know this midsegment is half the distance of this, but there's also a relationship about the directions of these lines. What's that relationship? They're parallel. And if two lines are parallel, what do you know about this angle and this angle? Because they are corresponding angles. Notice if I take this little triangle and I take the big triangle, this angle and that angle are there. But look at this angle. It's here and here. Anytime that you draw a midsegment, you are drawing similar triangles.
Yes.
I don't know if it was yesterday or on one of our construction projects in the last week, we actually drew a third segment. Actually, we saw that when we were doing a dilation yesterday. That we saw that, hey, if I just go a third of the way down, where this piece is a third of that and this piece is a third of that, this piece was also parallel. It does not matter what kind of segment it is, as long as this piece is parallel to that one, you're always going to end up in similar triangles. So, famous problems that are like this. Two city streets. We'll call this one Oregon, and we'll call this Washington. Okay, and then I have a whole bunch of cross streets. We'll call this like 6th, 7th, 8th, 9th. We'll call this 50 feet. We'll call each of these 50 feet. And we'll say that this distance right here is going to be 200 feet. And you can use those relationships to find the length of 8th Street, 7th Street, and 6th Street, because they're all similar triangles. So that's another typical problem that you will see using similar triangles. Okay? And these don't have to be straight up and down. Just as long as these roads are parallel to each other, that fact will work. Please turn your book to page 378. Problems 9 through 14. If you can prove that two angles are congruent to each other, then the triangles are similar. That's what they want you to do in that group of problems. Okay. For problems 21 through 24, I was going to assign all four of them, but I need to do one of them for you. So if you look at problem 21 to 24, they give you 3 points of a triangle, and they give you 2 points of a second triangle. They want to know the x and y coordinates of that second point to make the two triangles congruent. So I'm actually going to do one of those for you. I will do an even problem. That way you still have both problems left to check your answers in the back of the book. So I will do 22. Can somebody please read off the coordinates for problem 22?
A 0 slash 0.
Okay.
B slash 0 slash 3.
1, 2, 3. Okay.
C 4 slash 0.
1, 2, 3, 4. Okay. So that's A, B, C. This is the first triangle that we're talking about. Okay, next one.
Alright.
What's D?
D O slash 7.
1, 2, 3, 4, 5, 6, 7. And what it wants to know here is how far do I be out here? I want to know the coordinates of that point. Okay, and in order for me to figure out the coordinates of that point, all I need to know is the proportionalities for my distances. What's this distance here to here? Okay, what's this distance between here and here? 4. What's the distance between here and here? That's 4. So this total distance is?
7.
What's the distance here? We don't know. So we're going to call it x. So if this distance is 4 and this distance is x, what is the total distance?
4.
4 plus x. So here are the proportions I'm going to set up. I'm going to set up the total distance over the total distance equals my short distance over my short distance. And that will give me the x coordinate over here. So 4 plus x over 7 equals 4 over 3. Multiply both sides by 7. 28 thirds. Subtract 4. How many thirds are in 4 wholes? If you take 3 pizzas, and you cut them into, actually, if you take 4 pizzas and cut them into 3 slices apiece, how many slices of pizza do you got? 12. That's what I'm asking. So this is 12 thirds. 28 thirds minus 12 thirds is, 28 minus 12 is 16 thirds. And that would be the answer. So that's not the answer. Well, I don't want x. I actually want 4 plus x. So we're done here. X is 16 thirds. We don't necessarily need x. X is 28, which is 9 and a third. So that's how you find the coordinates of this other point. You're actually looking for 4 plus x here. So we didn't even have to go all the way to x, because the next thing I was going to do is I was going to add 4 back to that. And I go, wait a second, I just took 4 away from that. So your answer's here for what the coordinate of that point is. So the actual coordinate of this here would be 0, 28 thirds. So that's how you do 21 through 24. So you ready for homework?